Hello everyone, welcome to Easy Physics again. Today's topic is refraction of light. Let's look at some assumptions. Assume we have a medium here which is air, and we have another medium here, it is water. Both are transparent mediums, and there is a boundary between them, and there is a normal perpendicular to the boundary between the two transparent mediums, and this is the incident light ray. It makes an angle of incidence with the normal. This is the refracted ray. It makes an angle of refraction with the normal. And as you see, when light attempts to move from one medium to another one, it does not move in a straight line, but instead it is bending. In this case, from air to water, it is bending toward the normal. In some other cases, for example, if you have a boundary between two mediums, medium M1 and medium M2, and assume this is the normal, and if a light ray, for example, a light ray like this comes to the boundary between the two mediums, it can also move like this. It is moving away from the normal. Why? Because originally it was moving toward this direction. So, depending on the properties of the two materials, depending on the properties of two mediums, the light ray, refracted light ray, can either move away, can move toward the normal, can move away from the normal, or if they are the same mediums, it is not going to bend. So amount of refraction, either moving toward the normal or moving away from the normal, depends on the index of refraction of the material. What does index of refraction mean? How it is defined? The index of refraction of a material is defined with N equals C over V. C is the speed of light in vacuum, and V is the speed of the light in the medium. Let's look at the index of refraction of some transparent mediums. For example, in vacuum it is 1. In ice it is 1.31. In glass it is 1.46. How these index of refractions are calculated? Our formula for the index of refraction is N equals C over V. Let's calculate the index of refraction of the olive oil. Now, N will be equal to, C is the speed of the light. In vacuum, it is 300 millionths meter per second. 300 millionths, I am not going to write it. Divide by the 204 millionths meter per second. Again, I am not writing the millions. And if you divide these two, you are going to get 1.47. Okay, that's it. So let's go to next concept. You have two different mediums. The index of refraction of this medium is N1, and that of the second one is N2. This one is equal to C over V1, and this is C over V2. When light is moving from one medium to another, what changes? In this case, N2 is bigger than N1. And as you see, the wavelength in the medium which has smaller index of refraction is lambda 1 bigger than the lambda 2. And we also know that the velocity of the light in the first medium is bigger than the velocity of the light in the second medium. What changes when light moves from one medium to another one? If it is not perpendicular like this, it changes its direction. For example, look at here. When the incident light is coming to the boundary between the two surfaces, it is refracting. And also, what else can change? The direction can change, and the wavelength is changing, the speed is changing. What about the frequencies? Frequency of the light in the first medium and frequency of light in the second medium. To see the frequency change, let's go to an animation. As you see, there is a medium of index of refraction n is equal to n1 is equal to 1, and there is another medium index of refraction n2 is equal to 3. The wavelength of the light in the first medium is bigger than the wavelength in the second medium. To compare the frequency of the light in both mediums, please concentrate on the green dots in the both medium. The motion of a wave is the disturbance of the medium. As you see, the disturbance of the medium in both cases is the same. I mean, they are moving up and down. These 2 points are moving up and down with the same frequency. This means that the frequency of the light in both mediums are equal to each other. So then we are going to write that when light is moving from one medium to another one, the frequency of light does not change. Okay, let's look at some examples. What is the speed of light in chloroform? We know that n is equal to c over v. If we rearrange this formula, we are going to get that v is equal to c over n. And we know that c is 3 times 10 to the 8 meters per second in vacuum. And in this one, we are going to find the speed of the light in chloroform. The index of refraction is 1.51. Will be equal to, now as you see, 3 over 1.51 will be approximately equal to 2. That's why we are going to write 2 times 10 to the 8 meters per second. This is approximate. Okay, let's look at another example. What is the relationship between the index of refraction of materials n1, n2, and n3? Here we have three mediums. The index of refraction of this one is n1, this is n2, and this is n3. The comparison between the index of refractions can be done. Let's look at the movement of the light from first medium to the second medium. Is it bending? The light is bending toward the normal, or it is bending away from the normal? As you see here, the light waves are bending toward the normal. This happens when n2 is bigger than n1. I mean, when the light attempts to move from low index of refraction to high index of refraction, it is bending toward the normal. Let's look at the movement of the light from the second one to the third one. As you see, this is the incident ray, and the refracted ray is refracted toward the normal. Again, we can conclude that n3 is bigger than n2. So this is the relationship between the index of refraction of 3 materials, 3 mediums. Let's look at this example. Now, in this example, assume here is air. This medium is air, and the second medium is water. Here is an incident ray. And what will be the refracted ray? The first one, is it possible to be the first one, second one, or third one? As we know that the index of refraction of water is bigger than the index of refraction of the air. n water is bigger than n air. And as we know that when light is moving from low index of refraction to the high index of refraction, it bends toward the normal. So, but in this case, as you see, even though the light is moving from air to water, the first one, the second one, and third ray, they are all moving away from the normal, and all of these are impossible. Let's look at our last example. Again, we are going to look at if the incident ray refracts toward the normal or away from the normal. Here is a spherical surface, and this is the normal between x and y. I mean, the normal to the boundary between x and y. The light ray originally the light ray is moving toward that direction. But as you see, this is the normal, and it bends toward the normal. I mean, it has bended toward the normal. So if it is bending toward the normal, it means that it is entering a high index of refraction. So we are going to conclude that ny is bigger than nx. What about the relationship between the index of refraction of y and z? Let's look at the movement of the light from y to z. Again, as you see, the original direction of the light is this one. But as you see, here is the normal, and this is the refracted light. It has bent away from the normal. If it is bending away from the normal, it means that it is passing to a medium of low index of refraction. It means that ny is bigger than nz. But as you see, ny is bigger than nx, and also it is bigger than nz. But what is the relationship between nx and nz? In this case, we are going to look at the angles alpha and beta. So as you see, beta is bigger than alpha. So let's do the comparison of the nx and nz. Assume light is moving. Here is a source of light. The light is moving toward that direction, and then it will move in that direction. Why? Because if light is moving like this, it can also move back like this. So when it moves from y to x, it is bending away from the normal. When it is moving from y to z, it is again bending away from the normal. But in which case amount of bending is more? As you see, beta is bigger than the alpha. So it means that amount of refraction here is more. So it means that the difference between the index of refraction of y and z is bigger than the difference between the index of refraction y and x. If it is bending too much when it is moving to z, it means that index of refraction of z is smaller than the index of refraction of x. That's why we are going to conclude that ny is bigger than nx and it is bigger than nz. That's all. Thank you for listening. If any problems, please write your comments and then I will try to answer your questions. Thank you for listening.